Good morning, student. Welcome to Urban Pro. Today we are going to discuss again one more interesting topic, that is diodes and transistors. See, diodes and transistors are usually formed. We can make diodes and transistors from semiconductors. What is semiconductor? It is some material whose conductivity, electrical conductivity is more than that of the insulator, and conductivity is less than that of the conductor. Okay, but as the conductivity of a conductor is more than that of a semiconductor, then why do we will study, or why do we use semiconductor? The thing is, we human being, we like control. Once we have some control power upon something or someone, we get we get benefit from that controlling power, isn't it? Similarly, the current flown through a through a semiconductor can be controlled very precisely. That is why that semiconductor is useful in today's life, is very useful. The gadgets around you, whatever you take, headphone, mic, even AC, fridge, TV, laptop, desktop, whatever you open, there are use of semiconductor. There are diodes, there are transistors. Okay, so that is why we are going to discuss briefly diodes and transistor. Hope you will like this discussion. So diodes and transistor, our topics is, initially we will discuss first diodes. What are diodes? See, suppose this is a semiconductor. This is a semiconductor, some silicon or germanium, whatever. Now, how do we make this diode? We dope it actually. We dope it. Doping is there. Suppose initially, what mentally, not physically, we will divide this into two segments, and one segment is doped with major carrier hole, and another, in the another side, it is not doped actually. First we take N type and we dope a P type impurity in one side, then it becomes like this. So ultimately we will have, by what, by doping, we will get a structure like this. What are these? In brief, these are electrons, these are holes. Holes means nothing but the deficiency of electron or absence of electron. Okay, for example, suppose here a electron was there. Now when the electron leaves here, the position here, it leaves a hole actually, absence of electron. Okay, so this side majority carrier is, I am saying, hole. Majority carriers, so minority carriers, few electrons will also be there. Similarly, in the right hand side, there will be some holes. These are minority charge carriers in the right hand side. Okay, so we call the left side as P type. P means positive, and holes are said to be of charge, positive charge, and electrons are of negative charge. So this side is known as N type. So N type, and this side is P type. Okay, okay. So this is, what is this? This is actually a PN junction diode, P type, N type. PN junction. There is junction in between the P type and N type. So this is actually known as PN junction diode. So this is diode, kind of a diode. And some contacts are there. This is a suppose connecting contact, but we will draw this when we will be go through this chapter. We will not draw like this. There is a symbol, and the symbol is very simple. We will take the symbol. This is a symbol of PN junction diode. This side is P and this side is N. This is a PN junction diode. Let me make it little larger for better clarity. Here there will be no gap. This will be connected only. Okay, this is symbol. That's how we will be drawing this PN junction diode. Then we have to bias it. That is, we have to apply battery. Then only it will become, it will be useful. Otherwise, it has no work. It is of no use unless and until the biasing is applied. Okay, short. We'll discuss now biasing of diodes or diode, whatever we call biasing of diode. See, biasing of diodes mean we will just connect battery to it. Suppose we have a diode. This is a diode. Okay, let me draw it more precisely. Okay, what is this? This is a diode. Okay, now if we give, or if we will just, what we will do, we will add battery with it. Suppose this is the battery, and how I have connected here, as you know, this is P side, this is N side, and this is positive terminal of the battery, this is negative terminal of the battery. How I have connected here? See, the P type is connected with the positive terminal of the battery, and the N type is connected with the negative terminal of the battery. And this type of connection we call as forward bias. This is forward biasing. Okay, what happens in this case? In this case, once we connect the battery with this ideal diode, current flows through the diode. Current flows. So we'll write here current flows. See, the symbol is so chosen that it is the current is flowing like this, and here we can see the arrow. When a current will pass, it will pass the current. Now let us discuss another biasing where everything will be fine. Listen, I am just copying it. But I'll erase this currents, direction of the currents. The reason is I am going to change the polarities or of the battery. That is, now I'll connect the battery. Here the negative terminal, here the positive terminal. This is N negative terminal, this is positive terminal. You see the connection. The P type of the diode is connected with the negative terminal of the battery. The N type, the N side or N side of the diode is connected with the positive terminal of the battery, isn't it? So this type of biasing is known as reverse biasing. It is known as reverse biasing. In this case, no current flows through the circuit. So current does not flow. This diode will not allow the current to flow through the circuit. See, suppose the current, the charge carrier starts to move like this, but here they will be they will be opposed by the diode. They can't flow through the circuit. So that is why this stick, as if this is opposing the current. But for forward direction, when current comes from this, we can see there is a arrow type of, the shape is a little bit as if it is a arrow. So this arrow indicates the current will flow, and this stick indicates the current cannot flow. Okay, so that's how we can remember this, that for which biasing the current will be flow and for which biasing the current cannot be flown. Okay, so this is biasing of diode. See, we can say this as, for this forward bias, once we connect it, current will be flow easily. So as if this is a on, I mean current is flowing, this diode acts like a switch. How? It will be better if we discussed first reverse bias. See, when the diode is connected in reverse bias with a battery, no current flows. What does it mean? It as if it is in off state of a switch. Similarly, for forward biasing, it acts like a on state. The switch is on. Okay, great. So this is all about biasing of diode. Now we will check how this diode works, how this switch property works in actual circuits. So now we will be discussing on circuits where diodes are used. You already studied electrical current, electricity. We added the battery with resistance and we calculated voltage, current and all. Now we will include a diode in that kind of circuits and we will check how the current flows. Okay, so for the time being, you just keep it in mind that when a diode is connected in forward bias, current flows. When a diode is connected in reverse bias, current does not flow. So now we will move on to some circuits with diodes. Okay, for that, before going into the use of diode in circuit, let us first discuss a circuit where there is no use of diode is there. So this is a resistance. Suppose I take one more resistance here and I am going to connect them parallelly. So these are parallel connection. Now what I will do, I will apply a voltage source. Okay, suppose this is the voltage source. Suppose it is 5 volt and the value of the resistance is suppose this is 1.5 ohm and this is 1.5 ohm. Okay, then you tell me what will be the current through this, the current that flows through the battery. As you know, it is simple how to calculate it. Current means voltage by total resistance. Voltage is here 5 volt and resistance, it is nothing but the parallel combination of 1.5 and 1.5. See, the parallel combination of 1.5 and 1.5 gives 1.5 by 2, that is 0.75, this much ampere. So 0.75 we can write it as 75 by 100, that will go to the numerator like this. Then as you know, 5 if we divide it, uh, it will be 100 by, okay, so 5 and 75 1, so 15, isn't it? So okay, 100 by 15 ampere, let it be. Now what we will do, we will take the same circuit, but now we will just change the polarity of the battery. That is, it is 5 volt, fine. Now we will change the polarity, that will, this side will be negative terminal, this side will be positive terminal. So definitely the direction of the current will be altered, that is, the current will flow from this side, isn't it? So we want to current calculate the current here also. See here the current will be as it is, so I am not going to calculate again. It will be as before. Why? The direction of the current will be changed, but the resistance is same, the battery is same. Definitely the current, magnitude of the current will not be changed, isn't it? Fine. So till now, for using these two circuits, what we did actually, we just recapitulated a little the concepts that we already discussed earlier in current electricity chapter, isn't it? Now what I'll do, I will take the same circuit. I'll take the same circuit. Not only that, I'll add now diode. Now I will add diode. Okay, suppose I add a diode here like this, and I add a diode here like this. Okay, let me keep the orientation of the diode same. Okay, now first what we will do, we will keep the the terminals will be like this. Current will flow from 5 volt battery, will be divided here into two segment, will be divided here into two segment like this, and then current will be flown up to the diode. As we can see, the current will try to get into the diode, and as we can see, the diode symbol is showing arrows, so it is forward biased, so definitely it will allow the current. So current will flow through this, they will get added, and this was for earlier case, okay, and current will come back to the battery again. Here also the current will be as it is as before, that is 100 by 15 ampere. Okay. Now the what we will do now, we will just change the direction of the diodes. Before that, let us erase the arrows. So I erase the arrow. Then we will do what? We'll change the direction of one diode. Let me change the direction. Yes, it is changed. What will happen? So current will start from 5 volt battery, enter here, will come to here, will come to here. But as we can see here, there this diode will allow this arrow, allow this current, as here the arrow we can see, it is forward biased. So current will come out of this diode and will flow like this. but the current that entered here crossed this segment will be opposed here. The reason is the diode is in forward biased here. As you can see, there is a stick. It will not allow the current. So this current will not be allowed. So let me denote it. Suppose the current, main current is I, main current is I. It gets divided into I1 and I2. This I2 will be able to come out of this diode, but it will not be able to come out of this. The I1 will not be able to come out of this diode. So here I2 will be there, I2 will be there, isn't it? So here also it will also be I2. Actually, no current will be flown through this segment. No current will be flown. Then what will be the current here? So let me erase this arrow. The reason is actually no current will flow through the lower branch. Here let us calculate the current. What will be the current? Current I is equals to 5 volt, isn't it? 5 volt. Resistance is 1.5 now. It is 1.5. So if we multiply by 10 in numerator and denominator, it is 50 by 15 ampere. So here actually the current is different from the earlier cases, isn't it? The reason is here the diode is opposing the current in one branch. Okay, see, this is an example of how we can control current, isn't it? We are controlling the current, we are opposing the current flow by just adding a diode in opposite direction, correct? Now let us check one more example. Let us will definitely take the same circuit, but we will change here the both the direction of both the diodes. Okay, so before that, let me erase the arrows which indicated the current in the previous analysis. Okay, so we will add diode in opposite direction, not like that. It will be like this only. Okay, okay, this one fine. I'll copy this diode again. So both the diodes here are in reverse bias. So no current will be flown through this, no current will be flown through this. So here the current will be zero. The current will be zero in this case. Okay. So this was a brief discussion on circuits with diodes, how currents are allowed by diode and how currents are opposed by diodes. When it is forward bias, it allows current. When it is in reverse bias, no current is allowed for ideal diode. The case is little different for practical diodes like Zener diodes, p-n junction diodes. There are breakdown, avalanche breakdown, Zener breakdown and all are there, but we will not go into that. Now we'll discuss transistor briefly. Transistor. Okay. So what is transistor? Here also in the earlier case for diode, initially we took a semiconductor and we doped in two segments. One side the majority carrier was p type and in the other n type. But for to make a transistor we actually divide it into three segments, and the length of the segment is such that one having larger width, one having narrower width, another having moderate width. Okay, and Transistors are actually, there are two types of transistors, N type and sorry NPN and PNP. NPN, PNP. Let us draw or discuss side by side. So one is N type, another sorry, one is NPN, another is PNP. So suppose this is NPN transistor. Okay, this is NPN. We are going to discuss in little detail, and this one is not NPN, this is PNP. What does this NPN PNP mean? It means this side, this is NPN, so here this is N type doping. In this side N type doping is there. Okay, similarly NPN, this side also N, this side also it will be N, and the middle one will be P, that is positively doped, that is here holes will be there. This is N type, NPN transistor. And for PNP transistor, here the doping will be by the left side will be doped by hole, that is P side, majority carrier is hole, and P type, as the name suggests, PNP, PNP, again P is there, so here a P will be there. Here also the majority carriers will be holes and electrons will be there in the middle one. In the middle one. These three segments have name. The left one, this is, and this is. The name of this segment is emitter. This segment emits as if this segment emits the charge carriers. Okay, so let us indicate it. Let us indicate it like this. Okay, now the next one, this is known as base. This segment and this segment is known as base, base of the transistor. This is base. Okay, and the third one is collector. The third segment is known as collector. So I have shown you which one is collector, which one base, which one emitter. So emitter, base and collector. There are two types of transistors, NPN and PNP, but in circuit, when we'll be symbolize it in our copy, we'll definitely not draw like this. There are symbols how I'm drawing this. This is a line here, here. Okay, fine, very fine. There are some contacts here, and here will be a line. Okay. See, This is known as collector, this is known as base, this is known as emitter. And copy, paste. But there is little difference. What is the difference? This is NPN transistor. For NPN transistor, there is an arrow. This arrow is directed along the flow of current. Okay. But in case of PNP, the current enters into the emitter. The direction of the current is towards the emitter, not enter actually. The direction of the current is towards the emitter. Okay, so let me write it again here. This is for NPN and this is for PNP transistor. That's how we draw a transistor in copy book here and there. Now we will not go into the mechanism of this transistor. This is lengthy as well as little, this is time taking. So we will go on to biasing of transistor, like we discussed biasing of diode. It is forward bias, it is reverse biased. See here, as in case of transistor, here also we can see there is a junction. This junction is what? See, this is N type, this is P type, this is N type. So we can see a junction of NP. Here also we can see a junction of PN, isn't it? So basically here two diodes are there. In this case also, for PNP also, two diodes are somehow sandwiched, isn't it? Yes, it is. Here also, as the diodes are only there, unless and until we will bias them, we will apply some battery from outside, definitely this transistor is of no use. So let us bias these transistors, or we'll just discuss how many types of biasings are usually there in case of transistor. Like in diodes, we discussed two types of biasing, one forward biasing, second is reverse biasing. Now we'll know how many types are there, how many types of biasing are there for transistor. Okay, these biasing types of biasing are usually known as mode of transistor. So see, for NPN transistor, usually there are three types of biasing. For PNP, there are three types of biasing, but we will discuss biasing for only one, that is NPN. Okay. Okay, so let me write the heading: biasing of transistor. That is, it gives actually when we bias a transistor very systematically, then it is known as configuration of transistor, mode of transistor. Okay, so configuration of transistor. How many configurations are there? There are mainly three types of configurations. There are mainly three types of configuration. One is common emitter, common base, common collector. So let me write common emitter. Means emitter will be common here. Emitter voltage is common. Here common base. This is common collector. And we write CE, common emitter, common base CB, common collector CC. How do we How do we write, how we draw the circuit? For that, let me copy this one. Okay, listen, this here I will be drawing the total circuit. Here also the base will be common, so I'll keep it like this, and here common collector I will wish to keep it as it is. Okay, so it will be better if I keep the size little less. Okay, great. See, so three configurations of there, three types of usual biasing are there. So I am using black color for connecting wires actually. This is connecting wire. Then a resistance will be there. Resistance is there. Then again a connecting wire. Then here I'll keep some space for adding a voltage supply, and then here I will connect a wire from the collector. It will come again. I will add a resistance here, then again a connecting wire, and here I'll keep some space to add battery. Okay, see the common emitter, isn't it? NPN, I am talking about NPN, biasing of transistor. Here I am discussing for NPN transistor. Okay, see, for active mode there is some mode, some bias is required to work properly. There are active mode, cutoff mode, and saturation mode, but I am going to draw for the active mode. For that, actually, the base, listen, this is NPN, so this is N, this is base is P type, collector is N type, collector is N type. Here, the base NPN, let us talk about the emitter. Emitter will be connected like this only, it is common. Then the collector will be reverse biased. Collector is N, so a positive terminal of the battery will be there. Let us change the color. A positive terminal will be added, connected to the collector, which is N type. And here, what will be the case for this base? It will be also positively biased, forward biased. For when the base will be common, what will be the case? Base is common and biasing will be common from this base. So like this, I will connect here a resistance and battery. Okay, here also a resistance will be added and a battery will be added here. The resistance I am going to draw in red color, then a connecting wire, and here a battery will be connected, and definitely it will also be forward biased and it will be reverse biased. So here, sorry, the collector will be reverse biased always. So collector, as we can know, the collector is N type, so N, and it is connected with the positive terminal, and the emitter is always forward bias for active mode. Okay, so a resistor will be there, and here the biasing will be what? Forward. So emitter is N type, and here the negative terminal of the battery will be connected. Okay, now what will be the case for base common collector? So common collector will be like this. Common collector will be like this, and resistances will be added here. So let me connect to resistor with base and emitter. Then biasing. Before biasing, let me draw the connecting wire here, draw the connecting wire here. How the biasing will be here? Here, see, collector means N type and emitter means N type, base means P type, isn't it? So emitter is always forward biased, so negative terminal will be there and positive terminal will be here, and the base is reverse biased, so this one. This will be the common collector configuration. Using these transistors are used at amplifier, and many more uses are there. So let us conclude the class, conclude the discussion here. Diodes and transistors is very important in our daily life. So it is really interesting to go through in detail about diodes and transistor. So hope you all understood the thing that I discussed. If still you have any doubt, do contact me with my profile in Urban Pro. Good day.